You are all good.
Okay.
You are all good. So we are recording now. And everybody, go to the vacuum of space there, astronauts, and listen to four-time space shuttle astronaut Don Thomas tell us his story of how he became an astronaut and all that he has done.
Hey, good morning, everybody. How's everybody doing today? Hey, I'm excited to be with you today and as part of Janet's Planets program here. I used to live in New Jersey. I lived there for about 6 years. I worked in Princeton, New Jersey, and I lived in a small town called Titusville, New Jersey, which is right by Washington Crossing Park. So if you went to the park there where Washington crossed at Delaware, you know, back in the Revolutionary War, that's exactly where I lived, and I'm excited to be with you today. So good morning, everybody in Tom's River. Well, as you heard, my name is Don Thomas. I had the amazing opportunity to fly on 4 space shuttle missions. I was on Space Shuttle Columbia 3 times and Discovery once. I've spent a total of 44 days in space, and during that time, I went around the Earth all the way around 692 times. So I've seen a lot of our planet, and what I'm going to do this morning is to share with you a little bit about what it's like to live and work in space. We'll talk about how we eat and sleep and exercise up there. I'll show you some of my favorite pictures of the Earth taken from space. We'll talk about the landing, and then I want to take just a few minutes at the end to talk about some of NASA's future programs. And these are missions that some of you may get to participate in. And then at the end, we'll have time for your questions. Sound good? And just to let you know, I'm coming to you today from Baltimore, Maryland. So I just live maybe 2 hours, 2.5 hours south of you today. So let me get my presentation up. And can everybody see that? Okay, so let's go ahead and talk about living and working in space. So I always start with this picture. This is not a picture of me, but it very well could have been me. I was just 6 years old when the first American astronaut launched into space. And that was a long time ago, back in 1961. And at my elementary school in Cleveland, Ohio, where I grew up, they brought us all to the gymnasium. I sat on the floor, watched a small black and white TV. And as soon as our astronaut was in space, I remember sitting there saying to myself, I want to do that. So ever since I was a little boy, I knew I wanted to be an astronaut. I wanted to ride a rocket to space. I wanted to experience zero gravity floating around up there. So I always knew what I wanted to do, and it took me a long time and a lot of hard work in school to get there. I wasn't quite sure how to become an astronaut. We only had 7 American astronauts at that time, and I didn't know any of them. But the one thing I recognized early on was it was going to be very difficult. There's a lot of competition. Thousands of people apply to be astronauts, and then a small handful are selected. So I knew as a young boy, my only shot of ever becoming an astronaut and making it to space would have to involve me working hard and doing my best in school every single day. And I'm sure you've heard that advice before. Work hard, do your best. Work hard, do your best. You'll hear it from your parents, your principal, your teacher. And it's really good advice. Excuse me. Because you never know when something you're learning today is going to help you in the future down the road. So all through school, I always tried to do my best in math and science, but also reading, history, art, music, gym, whatever I worked on, I always gave it my best effort. After high school, I went on to college. I got my bachelor's degree in physics. It's one of the sciences, and that's the minimum degree you need to become an astronaut, a 4-year college degree in math, science, engineering, or the medical field. But again, I knew the competition was going to be tough, so I stayed in college, and I went to Cornell University in New York State and got my master's and my PhD, my doctorate in engineering. So after 9.5 years of college, I moved to New Jersey. I got a job with a company called AT&T Bell Laboratories there in Princeton, and I was doing research work for them. And it was at this point that they started applying to NASA to become an astronaut. NASA selects new groups of astronauts every 3 or 4 or 5 years. They'll pick a small group of 10, 15, or 20, depending on their needs. And 2 years after I got out of college, NASA put out that announcement they needed new astronauts. I was all excited. I wrote to them. I got the application form, carefully filled it out, sent it back in. And can you guess what happened? they turned me down. They said, no, thank you. We don't want you. I was surprised, but I didn't give up. 2 years later, another astronaut selection. I got another application form, sent it in, and guess what happened that second time? I got turned down again. So at this point, I realized I need to do more to get noticed by NASA because I wasn't even getting close in the competition. So being an engineer, what I did is I studied the data. I carefully looked at the backgrounds of the people that were successful getting into the program, and I wanted to see what do they have that I don't have? What am I missing? What education, what background, what experiences? And by studying that, I learned a few things. The first was most of the astronauts that NASA was selecting already had some flying experience. It wasn't a requirement, but it seemed to help. So I went to Trenton State Airport and I got flying lessons and I got my pilot's license. Also, I noticed that most of the astronauts that they were selecting had some skydiving or parachuting experience. So I went to one of the skydiving places in New Jersey and took lessons and learned to skydive. I also taught a university course. That seemed to be experience NASA was looking for. So I worked on those activities. 3 years later, another astronaut selection. I sent my application in, and this time NASA called me up and they invited me down to the Johnson Space Center in Houston, Texas for a week of medical testing and an interview. And out of the thousands of people that apply to be astronauts, NASA will select 100 individuals. They bring you to Houston. You spend a full week on a very thorough medical exam, and then there's a 1-hour interview. I passed all the medical tests. That all went very well. I went on to the interview, and that went extremely well. And at the end of my week in Houston, I was feeling really good about it. I thought, boy, it couldn't have gone any better for me. And it was about 3 months later, I got a phone call from NASA, and they said, Don, thank you for applying. We had a lot of good candidates. We did not select you, but good luck in the future. I hung up the phone and I felt like giving up. I thought, you know, I tried 3 times. I worked hard. I did my best, but NASA just didn't want me. So I decided, you know, it's time to give up on this silly dream of mine. So I knew I'd go to bed and get a good night's sleep. And then in the morning, I would put together a new plan for my career that did not involve being an astronaut. I went to bed that night. The next morning when I woke up, the very first thought that popped into my head was, I still want to be an astronaut. So I asked myself, are there any more of these little things that I can do to improve my background to make myself a better candidate? And again, by studying who NASA was selecting and who they weren't selecting, it was pretty clear most of the people they were picking were individuals that were already working at the Johnson Space Center in Houston, Texas. So I moved from New Jersey. I drove down to Texas. I got a job with NASA as an engineer working on the space shuttle program. I did that for 3 years. And then there was another astronaut selection. This is number 4 for me. I sent my application in. I got called up for the medical testing and the interviews, and that all went very well. And this time I got a call from NASA, and they said, Don, are you still interested in being an astronaut? Because we'd like to offer you the job. I said yes. I hung up the phone, and then I was jumping up and down, yelling and screaming for 10 minutes because I knew I'd made it into the program. I was 35 years old when I got that phone call, and I started a 4-year training program for my first flight. So the first time I made it to space, since dreaming from being 6 years old, the first time when I was in space, I was 39 years old. Now, 39 years old is pretty much an old man, right?
No.
Well, no, you guys are very polite. This is why I love New Jersey. And, you know, some of the careers you're going to pick, it's going to take a while to get there. So I encourage you, work hard, do your best in school every single day, and never give up on your dream. And I went from this little boy just dreaming of going into space to getting assigned on 4 space shuttle missions. This is the crew from my last flight, and the last time I was in space was 22 years ago already, in July of 1997 aboard Space Shuttle Columbia. We have 2 military pilots with the helmets that help us fly the shuttle. On the left-hand side with the helmet is our commander. His name is Jim Halsell. He was an Air Force test pilot. He used to fly the SR-71 Blackbird spy plane. On the right-hand side with the helmet is our pilot, and her name is Susan Still. And Susan was a pretty unique individual. She was only the 2nd woman to pilot the space shuttle, and Susan was one of our country's top Navy fighter pilots. So it was a great opportunity for me to fly with her on this mission. And then in the background, we've got 5 of our science astronauts. We're called mission specialists and payload specialists. Our job is to do the science on board. We work the robotic arm on the space shuttle if there's a need for that. We deploy satellites and do spacewalks. So we each have our area of specialty on the crew. I don't know if you recognize that guy in the far right-hand side, but that's the way I used to look 22 years ago before gray hair, wrinkles, and a few pounds around the middle that I don't think you can see here today. Okay, there you see the space shuttle on the launch pad, and I took this picture the night before my first mission. Went out to the launch pad around midnight or so with another one of the astronauts down at the Kennedy Space Center in Florida. And it was so amazing just to stand there at the base of your space shuttle and just look up at it with those bright lights and the pitch black sky behind it. And as I stood there gazing up at it, I had incredible butterflies in my stomach. A little piece of me was nervous, a little piece of me was scared, but my main emotion was one of great excitement because I knew 12 hours from when I'm taking this picture, I'm going to be sitting in the nose section of the space shuttle there blasting off. And I almost couldn't believe where I was and what I was about to do. So they bring the astronauts out to the launch pad on launch morning about 3 hours before liftoff. We take an elevator up on the left-hand side of the picture, and right near the nose of the space shuttle, you'll see a little access arm or bridge. And that's what we would walk across to crawl through a little round hatch or door in the side of the space shuttle. There I am in my launch suit 3 hours before liftoff, standing in front of Space Shuttle Columbia, and they strap us into our seats one at a time. So I'm just standing outside here waiting, and when it's my turn, they'll call out and say, "Hey, Don, we're ready for you." I'll turn that corner to the left, walk down that little access arm, and at the end of it there, you see the round hatch or door for the space shuttle. Before I climb inside, these 2 gentlemen in the white suits there will help me put on a parachute harness. We'll get our helmets on, gloves on. They'll do a last-minute check about my equipment, and once everything looks good, I'll get on my hands and knees, crawl on that white board, and go through that round hatch and get inside, where we have people that will help strap us into our seats. We're sitting, laying down on our backs, actually, for liftoff, so it's like sitting in a chair at your desk at school, but because the shuttle is tilted upright, we're actually laying down on our back. And we've got shoulder harnesses and seat belts. They strap us in good and tight because there's a lot of shaking and vibration during launch. You don't want to bounce out of your seat and hurt yourself or damage any equipment. So they strap us in good and tight. And once that's all done, they close and seal that side door there. Then everybody moves away from us 3.5 miles. And it gets very quiet inside the space shuttle up until about 6 seconds before liftoff. At that point, 3 big engines at the tail of the space shuttle start coming up to full power. And then 6 seconds later, we light those big white side rockets that you can see. They're called solid rocket boosters. They look like giant white pencils there. And the instant they light, boom, immediately you take off. And laying on my back in my seat, I could hear the roar of the engines. I could feel the shaking and vibration going on. And right at the moment of liftoff, I felt the push in my back. And it felt to me as if somebody had their hand right in the middle of my back and that they were just pushing me up into the sky. And that's what the space shuttle's doing, literally pushing us, tossing us up in the air. This picture is taken just 4 seconds after liftoff. We're going 120 miles an hour already. So we don't ease off the launch pad. It's literally boom, and we accelerate faster and faster every second. This is a picture taken from a NASA chase plane a few miles away, and you see we launch right along the coastline of Florida. This is just about an hour to the east of Orlando. So if you've ever been down to Orlando and Disney and some of the theme parks, you're just an hour drive away from the Kennedy Space Center. And you see our 2 round launch pads there. In this picture, we're launching from pad 39A, which is a very historic launch pad. This is exactly where Neil Armstrong launched to the moon 50 years ago on the Apollo 11 mission when they first landed on the moon. The space shuttle is just a tiny dot. You can't even see it in this picture, but at the top of that smoke column, you can see the bright flame from our engines. That's about 1/4 mile long. 2 minutes into the flight, we're 25 miles up in the air, and after 2 minutes, we're traveling at a speed of nearly 3,000 miles an hour. And our two solid rocket booster rockets have used up their fuel. They separate off to the side. They would fall back to Earth, parachutes would open, and they would land in the Atlantic Ocean about 150, 200 miles off of Cape Canaveral. And NASA would have ships in the area, would recover these, bring them back to the Kennedy Space Center, where we would clean them up, load them up with new fuel, and then use them again on another mission. So at the center of the picture, you see our space shuttle. The three bright white dots you see there are our three big engines that are burning. And just to the right of that, you see our big fuel tank. And that's going to take us the rest of the way to space. 8.5 minutes after liftoff, the engine shut down. It's perfectly quiet for a second, and then there's a big kaboom. We fire some explosive bolts, and the space shuttle separates from that big fuel tank. And that fuel tank would just fall back in the atmosphere and burn up like a shooting star. It was the only part of the space shuttle we did not reuse, and that would leave us then with the space shuttle orbiting the Earth. It only takes 8.5 minutes to get to space. That was always amazing to me. I'll bet it takes some of you more than 8.5 minutes typically to get to school in the morning. And think about it, in that short period of time, you could end up being 200 miles above the Earth. And at this point, we're traveling at a speed of 17,500 miles an hour. That turns out to be 5 miles a second. So imagine how fast you could get home from camp today if you could go 5 miles a second. Most of you would probably be home in 1 or 2 seconds, or if you live far from Tom's River, it may take you 3 or 4 seconds to get home. And we go so fast in the space shuttle that we orbit the Earth. We go all the way around it in only an hour and a half. This is Chaki Mukai. She was the first Japanese woman in space, and I flew with her on my first mission. And in space, you don't walk like we're used to doing here on planet Earth. When you want to move around in space, it just takes a little push with your finger, and you go sailing through the air like Superman or Superwoman. And you'll keep sailing until you hit a wall or until you reach out and grab a hold of something to stop your motion. If you like doing somersaults, you can start flipping in the air. And you'll go round and round all day until you get tired and you reach out to stop your motion. So what do you think? Does it sound like fun in space? Yeah. We have a great time floating around up there. Here's a picture of Susan, the pilot on my last flight. And Susan's typing on a laptop computer there. And I want to point out one feature. If you look at her toes, she's got her toes hooked on that vertical gold pole. If she didn't do that with her toes, every time she hit the keyboard on the computer, what do you think might happen? She'd go floating away, exactly right. But if she just pinches that bar a little bit with her toes, she can stay in position, float in the air, and type on the computer all day long. So space is a really fun, comfortable environment to be in. And in space, there's no up or down. I think we pretty much agree which way is up and which way is down here on Earth. But in space, there is no up or down. And you know here on Earth, if you stand on your head or hang upside down from a tree, all the blood rushes to your head from gravity. I'm sure you felt the pressure from that. In space, without gravity, that doesn't happen. You go upside down, you feel totally normal. And in space, wherever your head is pointed, that direction is up for you. Wherever your feet are pointed, that's down. So this is a picture of Nancy and Kevin on my second flight. And Nancy's looking at Kevin there saying, "Hey, Kevin, you're upside down." Well, Kevin's looking right back at her saying, "No, you're upside down." In his little world, she's the one that appears to be upside down. So in space, you never feel like you're upside down. It's everybody else in the room. Now in space, we don't have a refrigerator, freezer, microwave oven, nothing like that. So most of our food is freeze-dried, and it comes in small plastic packages. And you see one of our astronauts bringing it over to our food station. And I'm going to stop the video or the presentation for 1 minute and just show you. This is the type of food that we eat. It's freeze-dried, comes in these small plastic packages, so that when we want to prepare a meal, we have to bring it to that food station you saw in that last picture. A sharp needle will poke into that package. We can inject hot water. That dry, hard food will absorb that water, soften up, and after 3 or 4 minutes, it's ready to eat. we would just cut this open with a pair of scissors and then eat it with a normal fork or spoon right out of that plastic container. And as you see, all the food has a little blue dot of Velcro. Can you see those on there? And after we'd make our meal, we'd simply Velcro it to ourselves. Then you float over to a window and you could watch the Earth go by and you have your lunch or dinner right there for you. So how convenient is that? We don't use a dinner plate because what do you think would happen in space? It's going to float away. So everything in space has Velcro. We can stick it to ourselves. We can stick it up on the wall. Now, drinking in space is a little different. We can't drink out of a normal glass or bottle like we're used to doing here on Earth. If I had a bottle of water in space, I could tip it upside down to get a drink, and nothing would happen. Without gravity, the water is not going to fall or pour out of the bottle. So in space, we drink out of foil pouches like you see here. This is a bag of powdered orange juice. We've got powdered lemonade, powdered coffee, powdered tea. We bring it to that food station. The needle pokes in there. We inject the water. You can mix up the powder there with just with your fingers, and then you poke a straw in there and you squeeze it into your mouth. Does that remind you of something that may be in your lunch some days at school? Like a juice box or juice bag. Have you ever had a Capri Sun? Like an aluminum bag. That's exactly how we drink in space. And if I go back to my presentation here, you'll see on the right-hand side near the center of the picture, there's a bag of not tropical punch, a little bag of lemonade somebody made and Velcroed it to the wall to keep it from floating away. Okay. Now in this picture, I've got a bag of tropical punch in my hand. And I've squeezed that bag of punch and some of the juice got away from me. And what looks like a red golf ball floating in front of my face is actually a blob of tropical punch. Any liquid in space forms a perfectly round ball. It's from a force we call surface tension. It drives it into a sphere. It'll just float there in front of you. You could go up to it and gobble it in one gulp. Or our more polite astronauts will take a straw. You could poke it into that blob and drink it, and you'll see that blob get smaller and smaller and smaller and disappear. Now, exercise in space is very important. You know, here on Earth, I'm walking around using my leg muscles all day, and here on Earth, we're carrying things like your backpack and your books. But in space, to move around, it's just a little push with your finger, and you sail through the air. And everything is weightless in space. I could lift your car at home with one finger in space. So we don't use our muscles at all, and it's very important exercise. We had this bicycle we'd ride every day for about 45 minutes. We'd get your heart muscle going, get your leg muscles working, so that when you come back to Earth at the end of the mission, you're still in good shape. Another sneeze, excuse me. Thank you. So sleeping is a little different in space. The inside of the space shuttle's pretty small, maybe the size of your kitchen at home, and we did not have dedicated bedrooms. So when it's time to go to bed, we would take a sleeping bag, attach it to the wall, you just float up there, slip inside, zip it up, and you go to bed. We wear the dark eye shades that you can see in this picture because in space, we go around the Earth every 90 minutes, and we get 45 minutes of daylight, 45 minutes of nighttime. If you don't want the sun coming in your eyes all the time, you need to wear the eye shades. And you see how our astronaut has his arms crossed across his chest? You know, here on Earth, if I was to totally relax, my arms would fall to my side because of gravity. But in space, if you totally relax, the arms tend to come up and float right in front of your face. So can you imagine you wake up in the morning, you open your eyes, and the first thing you see right there are two hands floating in front of your face? Our astronauts are not that brave, so we tuck our arms in like you see in this picture. And the real reason we do it, off on the right-hand side, you see a lot of cables and switches. And you don't want your arm in the middle of the night floating over there, bumping a switch, hitting a cable, doing some damage. So we just try to get nice and secure like you see in this picture. Now for cleaning up in space, we don't have a bathtub, we don't have a shower, we don't even have a faucet, you know, a sink like you have in your kitchen or bathroom at home. So when it comes time to clean up, we have some of those little drink bags that I showed you. And instead of having powdered juice in those, a few of them will have powdered soap. And we could add hot water. you mix up a bag of hot soapy water. We would put that on a washcloth and just give ourselves a sponge bath. For washing our hair, we use a special shampoo that you see here called No Rinse Shampoo. And this was developed for people in the hospital who can't get out of bed to take a shower. It's very easy to use, doesn't require any water, and all you do is squirt some of that in your hair, you work up a lather, and then you take a towel and pat it dry and you're done. I took this picture. I love the bottom line on the bottle right there. It may be hard to read, but it says, "For beautifully clean, full-bodied hair." And I want to share with you what that looks like in space. This is Susan, our pilot, and anybody with long hair, it's going to float all over. And I'm not picking on Susan. Even my short hair floats all over. And we say that every day in space is a bad hair day, and that's pretty accurate. I want to share with you the granddaddy of all bad hair days in space. Are you ready for this one? Are you sure? All right, you better hold on. Here we go. This is Marcia Ivan. She flew on 5 space shuttle missions. She grew up in Philadelphia, not far from where you're at. And she had super long hair. And as you see, it's going to float all over. And she wouldn't leave it like this normally during the mission. Otherwise, for the rest of us, it'd be like scuba diving through seaweed. She'd put it in a ponytail, but just did this for the picture. Anybody know what this is? This is the toilet on board the space shuttle. And should we skip this? You guys want to hear about this? You know, the last time I did this presentation, the students voted me down. Are you sure you want to hear about the toilet? Okay, I gave you a shot. So this is the toilet on the space shuttle. It's in a small closet area, maybe the size of a, you know, like an airplane toilet if you've ever flown on a plane before. And it's got a curtain that goes across the front, like a shower curtain for privacy. And right near the center of the picture, you see a white toilet seat like our toilets on Earth. But here on Earth, we use gravity to collect the waste material. You could probably imagine what would happen in space. And we're not going to talk about that this morning. But this toilet is like a porta potty. You may see at a football game or a construction site. And in the bowl part of the toilet, there are giant fans. And to activate the toilet, there's a little white knob just to the left of the toilet seat there. You push that knob forward, it activates those fans, and it sucks air from the toilet seat downward. So we use this down rush of air to act like gravity to keep all the waste material down. And that is the secret to going to the bathroom in space. And in space, everything floats up there. If you're brushing your teeth and you want to rinse out your mouth, you can let go of your toothbrush and toothpaste, float across the shuttle, get a drink of water, and when you come back, your toothbrush and toothpaste should be floating in the air right where you let go of them, unless maybe one of your crew members came by and accidentally kicked it with their feet. Okay, we'll wrap it up by showing you some pictures of the Earth. And whenever an astronaut has a free moment, we would float to the window to watch the Earth go by. I've got a map in my hand here. I'm trying to figure out where we are around planet Earth. And I'm looking at one of the windows there towards the tail end of the shuttle. And I took a camera up to that window, I pressed it against the glass, and I took a picture so you can see exactly what my eyes are seeing. And this is the view I see out the back. So that is the beautiful blue Earth from 200 miles up. All the blue in this image that you see is the Pacific Ocean. The white areas are puffy clouds. On the right-hand side of the picture, that peninsula coming down is Baja California. It's part of Mexico. So San Diego, California would just be to the upper right-hand corner of that picture. And if you look very carefully at the bottom edge of the Earth, either to the right or to the left of the space shuttle, you might see a little thin blue line. Can you see that today? Can anybody see that blue line at the bottom edge of the Earth? Can you guess what that blue line is? That's our atmosphere, exactly right. On a nice sunny day here on planet Earth, you look up at that blue sky and it looks like it goes on forever and ever. From space, we see the atmosphere edge on. And it looks just like you see in this picture. It looks like a paper-thin layer. Most of the air protecting us here on planet Earth is in that first 20 miles or so. And that's about it, which is why when we pollute the air, it can have such a major impact on our planet. Here's a giant hurricane. I saw many storms when I was up there. This was a big hurricane over the Pacific Ocean, and it was nearly 400 miles across. And we flew right over the center of the hurricane. Does anybody know what that's called? The eye, exactly right. And from 200 miles up, I could go to the window, look straight down, look right into the eye and see the blue water of the Pacific Ocean. The next picture will show you the eye looking straight into it from directly overhead. Right there. And that eye is about maybe 15 or 20 miles across. And as you might know, in the eye, you get very light winds, just, few mile an hour breeze, but 7 or 8 miles away, you get the eye wall where you get the highest winds. And this was a powerful Category 3 storm, had top wind speed of 130 miles an hour. Here you see a volcano venting steam. This is in the South Pacific near Indonesia. On the left-hand side of the picture near the center, you see a volcanic crater half underwater there. And these are all volcanic islands in that part of the world. And here you see the Himalaya mountains. And right at the very center is Mount Everest. And so with that little arrow there, that's pointing directly to the top of Mount Everest. And I have seen the top of Mount Everest with my own eyes about 25 times during my missions. I call it the lazy man's way to see the top of Mount Everest. I've never climbed Mount Everest, never will in my lifetime, but I've seen the top of it many times. I've seen the Great Barrier Reef off Australia. I've seen the Amazon rainforest down in Brazil and South America. And I've seen Mount Kilimanjaro, big volcanic peak in Africa, poking up through the clouds. So many amazing sights around planet Earth. Does anybody recognize this beautiful part of planet Earth? Why don't you yell it out if you recognize where this might be? It's part of the United States. It's a really beautiful part of the United States. It's on the East Coast. It's New Jersey. Let me put a few landmarks in here. So there you guys see Seaside Heights, Island Beach State Park. You guys ever been there? I used to go swimming there, and there you see Barnegat Lighthouse there, and also Lakehurst. You can see the runways at Lakehurst. I don't know from where you're sitting. Can you see Tom's River there? You got to look carefully. Right there. There you guys are. Just a beautiful, beautiful part of planet Earth. And the whole state of New Jersey is so spectacular to see from space. And this is the east coast of the United States, taken at nighttime. And I'll put some cities in there so you can see New York, Philadelphia, Baltimore, Washington, down to Richmond. You can even see the bright lights of Ocean City, Maryland, and you see the brightest lights there in Atlantic City. And if you look just to the right, not too far from Atlantic City, you can also see Tom's River there, right there. And just up above Tom's River, just to the right, you see all the lights of New York City going up into Connecticut. Just spectacular to see from space. And here you see a sunrise from space. Because we go around the Earth every hour and a half, we see 16 sunrises and 16 sunsets every 24-hour day. And they're all spectacular, and I would try to see as many of these as I could from space. Well, at the end of the mission, it's time for us to come home. We'd fire 2 engines in the back of the space shuttle. It would slow our speed down just a few hundred miles an hour. But about 55 minutes later, we would end up landing on a nice long runway back at the Kennedy Space Center in Florida. Touching down on a runway, just like an airplane, we deploy a drag parachute out the back to help slow us down. We put the brakes on and just roll to a stop. And then we just sit and wait for them to open the hatch. And typically it would take them an hour or so before we could get out. And when you first come back from space, you feel like you weigh about 2,000 pounds. Because you've been floating around weightless for 2 weeks, and then suddenly you come back to this pull of gravity. Just a normal pull that we all feel here today, but it felt so heavy for me. My arms were heavy, my legs were heavy, I was a little dizzy when I got back, and it took a day or so for that dizziness to go away, and maybe a week or so to get your muscle strength back, and then you're pretty much back to normal. So here's a picture taken 2 hours after I landed on my first flight. That's me there on the left. And after we took a picture, I remember turning around and I looked up at the word Columbia, and I was just staring back at my space shuttle, and I thought, what an amazing vehicle this is. You know, this was my house in space for 2 weeks. This thing protected me from that fiery reentry coming in through the atmosphere. And then one of the next thoughts that popped into my head was, I got to do this again. And it's a lot like going on one of the great roller coasters at Six Flags. Have you ever been there? You get off the roller coaster and maybe you run around, get back in line and do it again immediately. And that is exactly how I felt as soon as I landed on my first flight. I thought, wow, I got to do that again. And I went on to fly a total of 4 times in space aboard the space shuttle. Now, our space shuttles have all been retired. They're all in museums. We've got Space Shuttle Enterprise up in New York City on the USS Intrepid, if you ever get a chance to go up there and see one of them. But they're all retired. We're no longer flying those. But we still have our International Space Station orbiting the Earth about 250 miles up. And this thing is huge. It's about the size of a football field. And the astronauts live in modules near the center of it. And they have the volume of about a 6-bedroom house. So they have a lot of room up on the space station. And they live up there for 6 months at a time. And these are the current 6 astronauts that are up there right now. We've got 3 Americans, 2 Russians, and an Italian astronaut who are currently up there. And we rotate the astronauts every 6 months. We'll send up a new crew. Well, NASA is building a new rocket today called the Space Launch System, SLS. And these will be the biggest, most powerful rockets ever launched. And instead of flying our astronauts in space shuttles or space planes, our astronauts will be in small capsules on top of the rockets. They're called Orion. And the Orion looks like this. It'll hold 4 to 6 astronauts. You see some solar panels there for generating the electricity. And during launch, our astronauts inside the capsule will be laying on their back, just like you see here, just like I did aboard the space shuttle. But unlike the space shuttle and coming back down like an airplane, these capsules will land via parachute in the ocean. And we'll have ships out there to help recover our astronauts, get them back to Earth, back to dry land, and get our capsules back as well. So our first test launch of this new rocket is just about a year away. And we call it Exploration Mission Number 1, or Artemis 1. And what NASA is going to do on this very first mission is send the Orion capsule unmanned. They're going to send it to the moon. And it'll orbit the moon for 10 days and then come back to Earth. And if everything works well on this first flight, they're going to put astronauts on the very next mission. And so we're just a handful of years of having astronauts being on the moon once again. So where are we going to be going with these new rockets and capsules? Well, I mentioned to you the moon. We'll be going back there. We'd also like to visit the asteroids. And we'd like to go on to that red planet. What's that one called again? Mars. Yeah, I always forget that name. So let's look at a few of these missions. Here's a mission to the moon. We'd like to build a lunar base to learn to live independent of Earth. And we hope to have astronauts on the moon there again, you know, in just about 5 years. We're going to try to set up a base near the south pole of the moon. Here's a mission to one of the asteroids. The scientists would like us to bring back pieces of these asteroids. These are early remnants of the solar system, maybe about 4.5 billion years old. And we also hope to send astronauts to the moons of Mars. Mars has 2 small moons called Phobos and Deimos. Wouldn't it be amazing to be that astronaut in the lower right-hand corner and you look over your shoulder and behind you there you have the giant red planet Mars floating in the background. And about 20 to 25 years from now, we hope to land astronauts on the surface of Mars. And this is an artist's drawing of that day. So you see our landing craft there in the center, and just to the right of it, you see the shadowy figure of the first 2 humans setting foot on Mars. And do you know who those astronauts are there walking on Mars?
You and someone else.
Me and someone else. I got to tell you, I'm too old to go to Mars. 25 years from now, I'm going to be almost 90 years old. So NASA's not sending me to Mars. I'm too old to go to Mars. Your parents are too old to go to Mars. And please never, ever repeat this at school, but your teachers are too old to go to Mars. But you are all the perfect age. We call you the Mars generation. And it'll be somebody in your generation there to be the first human to set foot on Mars. Which is why we say, you know, we need you. We're building these new rockets today at NASA, the Space Launch System. We're designing new spacesuits. We're designing habitats for our astronauts to live on the moon and on Mars. And we're going to need our scientists, our astronauts, our technicians, our engineers, all of them. We're going to need them ready to help us with these missions as well, which is why I'm so thrilled you're participating in the camp this week, and it's why it's so important for when you go back to school that you work hard and you do your best at math and science and all your other subjects so that you can help us be a part of these missions in the future. So with that, I just want to say thank you very much, and we'll go back to the big screen here and see if anybody here has any questions. Anything you want to ask here today?
Oh, we've got tons of questions, Don. So I saw your hand. Will you come this way? But you're going to step around here. I want you to sit in this chair. No, go all the way around. There you go. Have a seat there. All right. And here's the question.
How many missions do you have to go to space?
You don't have to go. You go as many missions as you want to. So I chose to go 4 times in space. Some of the astronauts fly 1 time, 2 times. We've had 2 astronauts that flew to space 7 times. That's the record. No human has been to space more than 7 times. Maybe you'll get to be that person. What do you think about that?
That sounds pretty cool.
Yeah.
Yeah. All right. Was that Jerry Ross, who's NASA's frequent flyer? He's done 7. Is there somebody else?
Jerry Ross and Franklin Chang Diaz. Both of them flew 7 times.
All right. This away. You say please, and maybe in a minute. So here you go. Have a seat. All right. And stand right here so you can see you. There you go.
What does it feel like in space?
You know, being in space in 0 gravity feels a lot like when you jump in a swimming pool or jump in the ocean and you're just kind of floating there. So that's what it feels like, you know, except the difference in a swimming pool, when you push off the side of the pool, maybe you go 5 or 10 feet and then you stop, the water slows you down. But in space, a little push with your finger and you just sail through the air. So the closest thing is to being in a swimming pool or jumping in the ocean. And I got to tell you, I love your NASA shirt there. It's just like the NASA logo I'm wearing on my uniform here today. I love that.
Thanks.
Have a great day.
All right. Next question. Have a seat.
How long does it take to get to Mars and back?
You know, to get to Mars, it'll be about 4 to 6 months to get there and 4 to 6 months to get back. But you're going to spend about 2 years on Mars. So the whole mission is going to be about 3 years long. And the reason you spend 2 years on Mars, we launch when Earth and Mars are close together. And then as soon as you launch, the planets start separating. And there comes a time when, you know, my left hand here is the sun, my head is, I'm sorry, the left-hand side is the Earth, my head is the sun, and Mars is on the right. That's a bad time to come back to Earth. So you have to wait 2 years for the planets to get close again, and then you come back to Earth at that time. So it's going to be about a 3-year trip to go to Mars. Are you ready for that journey?
Yeah.
I would love that you make it to Mars. That would be so exciting for both me and Miss Janet.
Absolutely.
What's the prettiest thing you saw when you were in space?
Wow, that's a great question. You know, I saw many amazing sights up there. Each sunrise or sunset is spectacular. But the most beautiful thing I saw was on my 3rd mission. When we were in space, there was a beautiful comet. It was called Comet Hale-Bopp, and it was near peak brightness. So as soon as the sun would set, all of a sudden I could see the bright comet there. And as I would watch it for about 15 seconds, it would slowly get lower and lower and lower, and then dip behind the limb of the Earth. And I remember on the first time I watched that, the comet just disappeared behind the Earth, and I was staring at the blackness of space, and I said, wow, I've just seen a comet set. I've seen sunsets, I've seen moonsets, but this was the first comet set that I got to see from space. And the really cool part was 90 minutes later, I could see it again. And then again and again, every 90 minutes, I could watch that comet set. Something else that was really cool to see from space was shooting stars. When you want to see a shooting star here on Earth, where do you look?
At space?
You got to look up at the sky, right? But when you're up in space and you want to see a shooting star, you have to look back at planet Earth. And the shooting stars are down there below you. So the first time I saw that, I'm looking down at some city lights, like passing over Philadelphia, and I saw a little zip of light go by. And I thought, wow, what was that? And then I finally realized it was a shooting star. But I was up above them. We're actually flying higher than those little rocks and pieces of dust that are entering the atmosphere and burning up. That was a great question. Thank you for that.
Yeah. You have someone correcting you that those are actually meteorites.
Meteorites. You're
Or
exactly
meteors.
right. They're meteors, and when they land on the ground, meteorites. And I should know better talking in a planetarium here.
Which spaceship has ever gone the closest to Mars?
We've had spacecraft that have landed on Mars. So we've had 4 rovers that are on Mars. First one was called Pathfinder. And then we had 2 of them, Curiosity and, I'm blanking out on the other name. And not Curiosity. Spirit and Opportunity, thank you. And then we currently have one called Curiosity that's driving around on Mars now. So we've had a number of landers land on Mars and 4 rovers. So we've been really close. The closest that any human has been to Mars is probably 70 million miles. You know, we've only been to the moon. That's as far as any human has ever been from the Earth.
Has any human tried to go to Mars?
The first time a human tries to go to Mars will be in about 20 to 25 years from now. And do you know who those astronauts are? Do you remember who's going to Mars? Is it me? It's you guys. You're too, yeah, I'm too old for going to Mars. You're the perfect age for that.
No, right now we're too young.
You're too young, but when it's time to go to Mars, you're going to be the perfect age.
Hey guys, I want this line to come over here and watch everything that's going on and know that I'm going to get everybody's question. Just be very gentle and go. Everybody watch.
Well, New Horizons.
Where is New Horizon?
Yeah.
The New Horizon flew past Pluto a few years ago, right? And it's heading out. I think it's going to be studying one of the objects, one of the minor planets that's further out.
Yeah.
Like Eris?
No, it's past Uranus and Neptune. It's past the big gas giants. It's past the orbit of Pluto.
Well, and it's like it's out there. New Horizons flew by Ultima Thule and took a bunch of pictures. NASA's going to take a look at all of that. And then guess what? New Horizons is going to keep going. And we'll see if they appointed any other mission to see if there's another near object that they can explore. Pretty cool, huh? Yeah. Huh? Yeah.
What was your favorite thing you saw in space?
My favorite thing that I saw, you know, seeing the comet set was great. I also liked looking at the Kennedy Space Center, our launch pads from space. And in Houston, Texas, that's where I lived. Most of the astronauts live and work in Houston. So I always enjoyed when we would pass over Houston, we'd all have our faces, our noses pressed up against the window. And I also love seeing Egypt from space. I could see the green of the Nile River there with all the irrigation, the crops. And with a pair of binoculars near sunrise or sunset, when there was a big shadow, I could actually see the Great Pyramids of Egypt. Really cool to see from space.
Yeah.
Here you go.
So what do you do when you're bored in space?
What do you do? When they keep us pretty busy working, we do a lot of science up there, looking at how plants and animals grow and behave up in space. But when we have time off, typically I would go to the window, put in some music, and just watch the Earth go by. But sometimes astronauts goof around in space. Do you guys ever goof around?
I always do that. So that's what I would probably be doing all the time in space.
Miss Janet, do they goof around or not?
They goof around a bit, yes, sir.
Well, we like to goof around too, and what we do when we goof around in space is sometimes we play catch. You ever play catch here on Earth?
Yes.
What do you use?
We just use like a soccer ball or something at
Well,
my
we
house.
don't have anything like that. So what we'll do in space, we have one of the astronauts will tuck themselves into a little ball, and then two of us can play catch with that person back and forth. So we have a lot of fun doing that. It is really funny to watch two people tossing somebody back and forth.
All right. All right, astronauts, go to the vacuum of space. We're listening to some great feedback from Dr. Don. So listen up.
Why did you choose to go only on 4 space missions?
Yeah, that's a good question. You know, every time you go to space, you take a risk that something bad could happen. We had 135 space shuttle missions, and I flew 4 of those. And of those 135 missions, 2 of them had bad accidents. The space shuttles came apart. All 7 astronauts died on those 2 flights. So there's always a chance, and you know that. So after I flew in space the 4 times, I just figured, you know, I would fly in space again if NASA would send me to the moon. I would fly in space if they would send me to Mars. But to go up on another space shuttle mission and do what I had done those 4 other times, I just didn't feel like taking the risk. So everybody decides for themselves. Some people fly once, 2 times, 7 times, and you just have to decide on your own how many times you want to fly.
Thank you. What's your question? Say it loud.
Good morning. I love your tie-dye shirt there.
Were you scared? Were you scared on your first mission?
Yeah, that's a very good question. And I was a little bit scared on my first mission, second mission, third mission, and fourth mission. And you should be a little scared during launch because there's always this chance that it could explode and break apart. So I compare it a lot to going on one of the great roller coasters like at Six Flags there. Have you ever been on one of those roller coasters and when the bar comes down, you're a little scared but all excited? And that's how I felt on launch morning. A little piece of me was scared and nervous about what I was doing, but I wanted to do this. I wanted to go to space. I wanted to explore. So my main emotion was excitement, but I was scared every time I did it, just a little bit. Good question.
All right. Yes, go ahead, Miss. All right, what's your question?
If you threw something in outer space, what will happen?
Say that again if you were...
If you threw something in outer space.
Okay. Inside the space shuttle, if you throw something, it's going to hit the wall and bounce around. If you could, if there was some way to open the window and throw an object out in space, whatever you threw out is just going to head out in a straight line, and it'll continue traveling in space forever until it hits something, or until the gravity of a planet or something else pulls it into itself. So you throw something out in space, and it'll just keep going in a straight line forever and ever.
That's pretty cool, huh? Yeah. All right. How about you, sir? All right.
When was the first time people went to space?
First time any human has gone to space was back in April of 1961. And it was a Russian astronaut. His name was Yuri Gagarin. And I was just 6 years old when he did that.
I can't imagine that. I'm only 7 right now.
He just can't imagine that. All right.
Yeah, pretty exciting. And let me just follow up with that. 600 people have traveled in space, a total of 600 people in the last about 60 years or so. That's how many people have made it to space.
Sophia.
If you throw trash in space, do you know what would happen?
Yeah, if you throw trash in space, 2 things happen to it. Even when you're up in space, there's still some residual atmosphere, so there's a little drag that'll slow that trash down. And slowly over time, that trash will fall back to Earth and burn up like a meteor coming back in the atmosphere. But we try not to throw any trash out because as you're orbiting the Earth, you could hit that object before it falls back to Earth. And if you hit a piece of trash going 17,000 miles an hour, it can do a lot of damage. It can blow a hole in the side of your shuttle. Just something small like the size of a marble could blow a pretty good hole. when you're traveling at 17,500 miles an hour. So we never throw anything out like that in space.
Can you see through Earth while you're in space?
You cannot see through the Earth, so all you see is the surface of the Earth. Just like when you're in an airplane, you look out the window, you see the Earth there, and maybe you see a few cities. Maybe you can see, you know, Trenton or Newark or New Brunswick. In space, you look out the window, and we see multiple, you know, countries at the same time. So you cannot see through the Earth, but we go all the way around it. So as we orbit the Earth, we see all sides of the Earth.
But he can see down through the atmosphere to the surface of the Earth. So great question.
Exactly right. We can see through the atmosphere when there's no clouds, but otherwise can't see through the Earth itself.
What country do you see that is like lit up the most at nighttime?
Boy, the East Coast of the United States is really lit up. Going from Boston to New York, to Newark, New Jersey, down to Philadelphia, then Baltimore, Washington. You see that whole East Coast, the I-95 corridor, we call it. And then you can also see Las Vegas is very bright. It's not as big as that whole East Coast, but there's a lot of bright lights in Las Vegas, Nevada, and they show up very well. Just like you could see Atlantic City, that shows up very well as well.
Have you ever seen a black hole in space?
You know, you cannot see a black hole because they don't give off any light. Their gravity is so high that if you were standing on a black hole with a flashlight, the gravity is so high that the light can't even escape. So we cannot see a black hole directly, but you can see the effects of it. Maybe you see a galaxy or a nebula being torn apart and sucked into a black hole. We think at the center of every galaxy that there are black holes. At the center of the Milky Way galaxy, we think there are black holes, and there's other ones out there, but they're not something you can see with your eye, and nobody's been anywhere close to a black hole. You don't want to get anywhere close to it, otherwise you would never escape. We'd never see or hear from you ever again.
Have any astronaut ever like tested to see if it was really a black hole or like a space or something?
Yeah, we have not been anywhere near a black hole. Again, the farthest we've been from planet Earth is just the moon, and there are no black holes in the vicinity of the Earth, the moon, or the sun. We think many, you know, hundreds of light years away at the center of our Milky Way galaxy, we think there are black holes there, but they're not all over in space. There's a lot of them, but you know, as you're traveling to Mars or a mission like that, you don't have to worry about black holes.
But one day you could work for the team that just discovered and mapped the first ever black hole. I'll have to tell you all about that. Sound good? All right, here we go. Another NASA hat here.
What was your favorite part about being in space?
Oh, that's a great question.
Yeah, you know, I love floating around. It was a lot of fun doing that, just floating through the air and playing catch with somebody. But my favorite part of being in space was looking out the window, looking back at planet Earth. You know, to be able to see the top of Mount Everest with my own eyes, to see, you know, the Kennedy Space Center, all these incredible sights. I told you I saw the pyramids of Egypt, you know, the Nile River there. It's just so amazing to see all of that with your own eyes from space. These are places I'd only visited in books at the library, and here I'm looking out the window, seeing with my own eyes the top of Mount Everest. So I always loved, every free minute I had, I would be at the window looking out.
Thank you. All right, you ask your question here, sir.
What would happen if something went wrong after the main engines ignited before the solid rocket boosters did on the space shuttle?
Yeah, if before the solid rocket boosters light, and that's about 6 seconds as those main engines are coming up. If there's a problem with those engines, the computer will shut down the engines there. And we're still bolted to the Earth. So the solid boosters, they won't light until those 3 engines look good. Once you light those solid rocket boosters, you're definitely going somewhere that day. There's no shutting them down. But any point up until that second where we light the solid rocket boosters, the computers can shut the engines down. And we call that a pad abort, and that had happened many times in the space shuttle program. I have a few astronaut friends. They were on one mission. They had 4 pad aborts, you know, 4 tries before they actually got to fly their mission. They were having a lot of problems with the engines and other equipment on board the shuttle, and the computer shut the engines down.
Ugh.
All right, thank you. Great question. All right, we've got a few more questions, Don. Thank you for taking so many.
Sure.
Why were you scared on your first mission?
I was scared on each of my missions because even though the space shuttle was as safe as we could make it, every now and then there's a accident. You know, we had a problem. 2 of the space shuttles, 2 of the 135 missions over 30 years, 2 of them blew up. One of them blew up just a minute and a half after launch. The other one, the space shuttle came apart as it was coming down to land at the end of the mission. And you know that's a possibility. It probably won't happen, but there's always a chance. So I was always just a little bit scared that this thing could blow up during launch, because where I'm sitting in my seat, I'm about 6 or 7 feet away from 500,000 gallons of very explosive rocket fuel. And if anything bad would happen in any part of the shuttle, the whole thing's going to blow up. And that's why we're putting the capsule on top of the rocket again for our future astronauts. It's much safer. If the rocket blows up, the astronauts are up on the top of it. We can separate from the exploding rocket, and those astronauts can come back down and hopefully survive an accident that way.
And that's pretty smart. We talk about engineers are always designing and redesigning, aren't you, Don?
Always, all the time, and fixing problems.
What does the moon look like?
You know, I've never been to the moon. So the closest I've been to the moon is about 200 miles closer than you've been. And the moon is about 250,000 miles away. And there's a lot of great images of the moon taken from the Apollo astronauts 50 years ago. You can go online and look at those. I'll bet they have some around the planetarium. But the moon has a lot of craters on it. And if you go to one of the observatories where they have telescopes, I'm not sure the closest one to Tom's River, but in Trenton, I know they had a observatory there. Some universities have them where you can look through a telescope and you'll see the craters, and you'll see huge areas of the moon there that are covered with craters.
How does the moon look from space, from your perspective?
From space, it looks the same as it looks here on Earth. Because we're not that much closer. We're just 200 miles closer to it. So the moon looks the same. The sun is brighter in space. It's more intense. The light is much, much brighter in space because it doesn't get filtered by our atmosphere. But the one thing that's a little different in space are the stars. You know how the stars twinkle at nighttime here? That's from a shimmering effect. As the light comes through the atmosphere, it causes a shimmering or twinkling effect. But in space, we're up above the atmosphere. So in space, the stars don't twinkle. They're steady, steady pinpoints of light. So you'll never hear an astronaut singing that Twinkle, Twinkle, Little Star song in space. But the moon looks very much the same as it does here on Earth. Same size, same brightness. It didn't look any different to me.
Thank you. All right. Couple more, Don.
Was the first astronaut to go in space, did he intend to go in space, or was it an accident?
No, nobody has accidentally gone into space. So the first human to go in space was Yuri Gagarin. He was a Russian astronaut. We call them cosmonauts. And you have to train for many, many years. He trained for 3 or 4 years before he did his first flight. The first American to go in space, his name was Alan Shepard. He grew up in New Hampshire. And he also trained for many years. His background, he was a military test pilot. So he flew jets. He had 4,000 or 5,000 hours flying jet aircraft. So all of our astronauts trained for many, many years for the opportunity to go in space. When you go to Mars on your mission, you're going to train for 3 or 4 or 5 years for that. So you won't accidentally go to Mars. You know, you're going to have to really want to do it, train, and then on launch day, you're going to be saying, I'm ready to go to Mars. I want to do this. I'm all excited. And maybe you could be that first person setting foot on Mars. I hope you get to make it there.
Me too. Oh, you have another question?
How did anyone discover space?
How did anyone discover space? You know, the first humans, they just looked up at the dark sky at nighttime And they saw the stars there, and they started wondering, what are those little points of light? And then they would see the moon moving across the sky and wonder, what is the moon? How far away is it? How big is it? And it took many, many years for us to really understand what was going on, what planets are, what moons are, what stars are, that there's different galaxies, many, many galaxies out there. So I don't know who the first human was to stare up at the sky and look at space, but that was many, many years ago, some of the very first humans who got to stare up at that. We did not begin exploring space until maybe in the 1950s or so. We started sending rockets up to measure the magnetic field of the Earth, to measure the pressure, how much atmosphere, how much oxygen do we have in space. So we started probing the atmosphere in the 1940s, 1950s with balloons and then rockets. But the first time, the first human to ever look up at the sky and discover space, that's somebody long gone.
All right, thank you. Great answer. All right, couple more.
Have you ever seen something weird in space?
I did see a weird blinking light on my first mission. And I'll tell you this quick story, but you all have to promise me it doesn't leave the planetarium, okay? All right. Well, on my first mission, I'm looking out the window of the shuttle, and I notice a light flashing out there. The sky is pitch black, and this light is flashing once a second. And I notice that it's moving with the space shuttle. I can see city lights down below. This thing is not down on Earth, so it's moving with us. So originally I thought maybe I'm looking at an alien spacecraft up there. But I studied it for about 10 minutes or so, and I finally realized what I was looking at. And what it turned out to be was a big chunk of ice. And this piece of ice was flipping end over end. And it had a flat side to it. And it was like a mirror. So when the sun would hit it, it would give you that flash. So what I thought was maybe an alien or another spacecraft, it turned out to be a chunk of ice. So we see weird things in space. But if you study them, if you're a good scientist and just study it, you can usually figure out what you're looking at. I don't know anybody who's seen any other spacecraft up there, but I do think there's other life in our universe.
I saw a perfectly shaped circle cloud. It looked really weird. I don't know what it was.
We've got some cloud formations that almost look like flying saucers too. These are natural things. They're kind of rare, but during some storms, they'll form these circular clouds up high in the sky.
It's on a bright sunny day, though.
Wow.
Wow.
So you never know. You never know. You got to keep studying it.
Yeah, you may become a meteorologist. Come on down. All right, this guy's got a great question. I can't wait to hear it.
From your view in space, did you see if the Earth was flat or round?
Yeah, from my vantage point, and I told you I went around the Earth 692 times, right? Mm-hmm. And every single time that I orbited the Earth, it was round. It was never flat once. So there's some people who think the Earth is flat. That is not true at all. And you can tell them that Don Thomas, who orbited the Earth, went around it 692 times. He said not one time did he go around the Earth and ever saw it flat. It was always a round sphere.
That is a great answer we can give to flat earthers. All right. Just a few more. They're loving this, Don, so thank you for your time.
What was the funniest thing that happened in space?
The funniest thing that happened in space, you know, tossing somebody back and forth playing catch with them was pretty funny to do. We try not to do many practical jokes up there because you don't want to go up to somebody and go, boo, and try to scare them. You don't want to scare anybody up there. So we try not to do that practical jokes like that. But funny things, you know, we had an experiment with fish. We had a round tank that had 6 fish in it. And fish will orient themselves wherever the light is. They think that's the top of the lake, and they'll orient themselves. So this round tank we had a light on the top and one on the bottom and then one on each side. And we turn on the top light and the goldfish would think, okay, that's the top of the lake, and they would all be swimming upright. And then we turn off that light and turn on the bottom light, and the fish would say, oh, I'm upside down. And you'd see them flip upside down and start swimming like that. And then you turn off that bottom light and turn on the side light, and they'll say, oh, we're crooked, and they would start swimming sideways, thinking that that's the top of the lake. And it was pretty funny to watch them change their orientation as they reacted to the lights. And one of the scientists was studying their behavior in space. But that was a fun science experiment to watch in space.
Awesome.
How many years would it take to get to Neptune?
To get to Neptune is probably going to be on the order of 8 to 10 years. You know, when we sent New Horizon to Pluto, it was 12 or 13 years for it to get there. So Neptune's going to take a long time. Hold on 1 second here. Okay, my dog was scratching at the door, so I had to let her in here. Sorry for that earthly interruption.
Oh, no worries. All right, ask your question.
What do you eat in space?
You know, our food is freeze-dried like I showed you, and we've got freeze-dried macaroni and cheese. We've got
Yummy.
spaghetti and meat sauce, hamburger patties. So we have a wide selection of food up there. And
You
none
got
of
the
it,
good food.
we got the good food, macaroni and cheese, spaghetti and meat sauce. My favorite was beef and barbecue sauce. That was one of my favorites in space.
Awesome. All right. 4 more questions, Don.
Okay.
Have you ever touched a cloud?
I've touched a cloud. So have you. If it's ever been foggy, you go outside, and fog is nothing more than a very low cloud.
What does it
Oh.
feel like?
It's just moist. Have you ever been outside when it's foggy in Tom's River? You could feel the humidity. It's moist there, but a cloud doesn't feel like anything. Hey, Janet, could I take a 30-second break here?
Sure. Hey,
Okay.
guys, while Don does that, I want you to be sure that you're gathered everything. These are going to be the last questions. If anybody has additional questions, we can email Don. So if you got to go to the bathroom, that's something to do. But can we just, it's like 30 seconds. We've got 4 questions. And Kevin can take you, Michael. But oh, that's a great one. No. Hey, guys, we're not all leaving right now. So just, we've got 4 questions. We're about to take, oh, and Lucia has a question. So we're going to wait for Don to take care of his animal, unless it is mission critical. Here he's back.
We're
all
back.
right.
I just had to let our dog out. Sorry.
Will people ever go to the outer solar system?
You know, sooner or later, people are going to travel farther than Mars. So we want to go to Mars, but that's not the destination. You know, we're going to keep exploring. This is what humans do. Today, it's really difficult to go farther out. Like I told you, to go to Pluto, if you were going to go to Pluto, visit there for a day and then come home, it would take about 25 years to do that. So it's a long, long trip. To go to other stars, if we found an Earth-like planet around another star, to travel to the nearest star, to the sun, you know, would take astronauts today over 1,000 years to get there with conventional rockets that we have. So we need our next generation of scientists and engineers to maybe come up with ways to travel in space that's a little quicker than we can do today. And once we can do that, then we can start exploring deeper out. It'd be really difficult to go farther out, you know, in our solar system. It would just take so long to get there. But humans will do that because we explore. We're always exploring.
Would it be possible to build a spaceship that gets into space using like a helicopter propeller?
Well, a helicopter propeller is only useful when you're in the atmosphere.
Yeah, that's what I mean.
And I told you the atmosphere is about 20 miles thick, and you got to
So
go up
that's-
about 100 or 200 miles.
to get
And
up
once you
to the atmosphere.
once you get above the atmosphere, that propeller won't do you any good.
Yeah, I know that, but like to get up into the space, not necessarily through space, but into space.
Yeah, you'd need a huge propeller. You can't carry enough weight. You can't get that speed going fast enough to escape the pull of gravity and make it up into orbit. So I don't know. I don't know how you do that, but maybe that's something you can work on as an engineer in the future.
I know he may be coming up with a whole new invention, Don.
He's got
3
some
more
great
questions.
ideas.
You're just so popular, Don. 3 more questions.
Can black holes suck up black holes?
I think a huge black hole, maybe some of our people in the planetarium know better, but a big black hole can suck up a smaller black hole. So whatever has the most gravity, it's going to win that battle.
Don, this is Lucia, and she has even written her questions down. So here she goes.
Good morning, Lucia.
What planets have you visited?
The total list of the planets that I visited?
Yes, that's the question.
Okay, the total list of every place that I visited, Earth. That's it. So we've had 12 astronauts walk on the moon, but nobody else has been there, and nobody has been to another planet. So the first time that a human leaves Earth and goes to another planet is about 20 or 25 years from now. And who are those astronauts going to be? Is it going to be me?
It's going to be you. All right.
I'm too old. It's going to be you and your generation. Yeah.
Was all of the hard work and training you did worth going up to space?
You know, it took me until I was 39 years old to make it to space. And 39 is like an old man, right?
No.
You're so polite. I love that. Yeah, it was worth it. It took me a long time, a lot of hard work, 10 years in college, but it was so worth it 1,000,000 times over. I would do it, if I could relive my life, I would do it the same way. I would work even harder to get there sooner, to get up to space. So all the hard work that you put into your school today, right now, it will pay off for you. Whatever career you want to choose, if you want to be a teacher, a doctor, a scientist, an engineer, an astronaut, if you want to be the first person on Mars, whatever you want to do, all the hard work that you put into your time now in school, it'll pay off big time. And if I asked you that same question, was all that hard work worth it for you when you were my age? You'd be sitting there nodding your head, say, oh yeah, it was worth it because I had a great life.
Thank you.
You're welcome. I love your NASA cap there.
Hey, I have a funny feeling about Samantha. I think she's going to be an astronaut. She was taking copious notes throughout your presentation. So take a good look at this face here. Look at that face. This might be our first woman on Mars.
Hey, and Samantha, if you make it to Mars, you got to promise to call me when you get back. I want to hear about the journey, okay? We'll do a pinky.
All right.
High five on that one.
Oh, and we've got plenty of astronauts in this group, Don. Everybody say bye, Mr. Don. Thank you so much for your extra time.
Bye-bye.
All right. We'll see you soon.
Day there.
Check your email later tonight. Take care. Bye-bye.
Bye-bye.
Bye.